students, welcome back to physics lab. Today we are going to start with a new experiment and we'll perform the experiment in the lab. But we need to know the theory of the experiment. So what is the aim? Aim is frequency of AC means. So by the way, when we think about AC and DC, this is a part of our syllabus. So let's learn what is AC. The current of constant amplitude which continuously varies. A current of constant amplitude continuously varies in magnitude with time and changes its direction periodically. You can see that direction is changing. Can you see this graph? This is a graph of AC current or AC voltage. You can see the current keeps on increasing. So its magnitude is changing, becomes maximum, then keeps on decreasing, becomes zero, then it reverses its path. It comes down, again maximum, and again starts decreasing. So this is what is AC. Now, you have heard about DC, direct current. The current keeps on, this is direct current. The current is constant with respect to time. It's a steady DC current. If I have to use a battery, which is like a cell, then after some time this current will start decreasing. But if you take a steady supply of current like illuminator, you will get a steady DC current. Its direction is same, it's unidirectional and its magnitude does not change. This is DC and this is AC. Now, if you go to see this AC alternating current, it's like a sinusoidal wave. It's like a sinusoidal wave. It does not move sinusoidally, it is the performance. For example, I take a resistance wire and I pass a AC into it, AC current. Can you see this symbol? This is the supply, AC supply. When the current moves, the current will go like this and then comes back. It moves like this and comes back. So you can see that the current is moving up and down. So in the wire which we are going to use in the sonometer experiment. So we are going to do an experiment called sonometer. You have done last year, but this year experiment is slightly different. Last year you used the tuning forks and this year we are going to use the AC mains supply. Now do you know what is AC of our mains alternating current frequency? Since it is moving up and down, it will be having some cycles. So this frequency is 50 Hertz. In India, in US it is 60 Hertz. So this frequency is 50 Hertz, that is the frequency of AC is 50 Hertz. So what is the meaning of that? It completes 50 cycles in 1 second. It completes 50 cycles in 1 second. Now what is the time taken by one wave, one oscillation? It will be nothing but 1 by n. That is T equal to 1 by n, which is 1 upon 50 seconds. Now I will ask you a question. How much time is taken by half of this wave? It will be nothing but 1 upon half, 1 upon 100 seconds. So this is the background we need to know in this AC. Now AC, look here. I will now briefly tell you how the AC changes. At time t equal to 0, let me call A, B, C, D and E. At the point A, time t equal to 0, current is 0. At the point B, time t equal to t by 4. At this point, current is maximum. Now how is the current? Current is moving in one direction in the wire. Current is moving in one direction. Now the current starts decreasing. Current starts decreasing at the point, at this point, and then at the point C, you will see that the current has become again 0. Now its direction has to change. So I will write direction changes. And then at the point D, current is maximum, but in the opposite direction, and at the point E, current becomes 0. This is what we get in this particular performance of AC with respect to time. So at every instant of time, current magnitude changes. That's all about AC. Now, you know very well, aim of the experiment is to find the frequency of AC mains and what is the apparatus required. So, look at the circuit diagram. First thing is transformer. You can see it's a step down transformer. Primary, there are more number of turns, and secondary, there are less number of turns. Here you can see that AC supply 220 volts from the mains, and this 220 volts is brought down by the step down transformer to 12 volts. Now we have a box wherein transformer box where we can vary it from 2 to 12 volts. In the lab I have taken 6 volts. I don't require 12 volts. So this is the. Now what is the reason behind using an AC? Means you are getting 220. Think of it, this transformer wasn't there and we were directly connecting this wire, connecting it to the mains. Then what will happen? It will so happen that this is a live wire and you are passing a current through a live wire. So you may get a shock, excessive current, 220 volts AC. So this current, which we may get a shock and it may prove to be fatal, and therefore we are using a step down transformer. Required voltage is not more than 12 volts. Then comes after the transformer is the key, the ammeter, which measures the AC current. We are going to keep the current not more than 1 ampere. After that is the rheostat, which is going to control our current. And then we are connecting this with the crocodile pins. Crocodile pins, you will see in the lab. So these are the pins connected here and we are passing the current. Now the current is flowing in one direction. At every instant of time, at one moment it is 0, then it keeps on increasing, and then the current becomes maximum, it keeps on decreasing, against 0, and then it reverses its path, AC current. So it moves like this. Now at one instant of time, the current is flowing, and you can see here there are two magnets facing each other. Sometimes we use electromagnet. In our lab we are using these two magnets, bar magnets, and they are facing each other. And these bar magnets, north is facing south, it is tied with the rubber band so that they don't come together, because north will definitely attract south. And we have kept a small distance between the two magnets and a wire is going through it. So what happens is wire is under the action of uniform magnetic field which is perpendicular to it. And haven't you heard this kind of thing in the chapter called moving charges and magnetism? What have you heard? There is something called as magnetic Lorentz force. Look here, this is the current flowing in the wire. This is the direction of magnetic field from north to south, and the wire will be pulled upwards at one instant of the cycle. Now I just turn it like this. The current is moving this way. Magnetic field remains the same and the wire will be pulled down. How long? Up and down the wire will be pulled. Now think of this situation when the wire vibrates. Definitely you will get the vibration here. But we need to go to a certain length. So we are increasing this knife edges distance. Distance between the two knife edges. At one particular point. This is the major point. At one particular length, the external frequency of AC, that is 50 Hertz, matches the frequency, natural frequency of the wire, and that is the time this wire will vibrate with maximum amplitude. And you will definitely see a beautiful loop in the lab. How beautiful it looks. Just one loop you are getting, vibrating with maximum amplitude. We are also keeping one paper rider on top of it. A very heavy paper rider, not the one which you used last year. Heavy paper rider. So that paper rider will fall when it reaches a maximum value of amplitude. So that also we see. We will perform the experiment. And then tell me one thing. What kind of mode of vibration, what kind of wave is produced? The wave produced is a stationary wave. And this stationary wave vibrates in one mode of vibration. When you get only one loop, like this, that time it is called as fundamental mode of vibration. You get one loop. These points are node and this is an antinode. So these points are node and this in the middle is the antinode. So near the antinode we have kept the paper rider. So this is what we get, resonating length. Have you seen one thing over here? We have suspended some tension, that is mass, First time you put a mass as a hanger mass as 200 grams. So pulley here, then 400 grams, 500 grams, and we keep on increasing and take 4 different readings for different masses. As the tension goes on increasing, it's a mass suppose is 200 gram. Okay, that means it is 0.200 kg. Now this 0.2 multiplied by 9.8 G. M into G is tension. So 0.2 into 9.8, what we get is the tension in the first instant. So that we will be seeing in the observation table and we will be performing the experiment. Now the first reading is over. Like that we have to take 4 readings. Now one more thing here, this wire is a non-magnetic material and it has got some weight. So we have found the weight of mass of that wire, and suppose the mass of the wire by chance is say 1 gram. We'll see what we get in the lab. It's say 1 gram per meter. It is called as linear density. It is called as linear density. So what is linear? 1 gram per meter. But what are we doing? We are finding everything in SI system. So definitely 1 gram upon 1000 is 0.001 kg per meter is the linear density. This you remember. So these are the observations we will be taking in the laboratory. After taking 4 readings of tension, we are going to find out frequency of AC means by using a formula. N is equal to 1 by 2L root T by M. Remember, this N is the frequency of the wire, which is equal to frequency of AC. Frequency of AC. This is frequency of the wire, which is equal to frequency of AC. Now let's do the calculations. We need to find out frequency of AC. What is resonance? The natural frequency of the wire, that is this, is equal to the external periodic frequency, that is AC. So if we find this, we find the answer as frequency of AC means, because the principle is resonance. Look here, N frequency of the wire, L resonating length, T is the tension, which is M into G, M is the mass per unit length. Then we just modify the formula and we get M is equal to square root of G upon 4M, M upon L square. Now let's do the laboratory and perform the experiment and find out what is the frequency of AC means.